Hello, this is part 9 of 2D platformer. Getting right deep into it now with our enemy class. And last time we were here, what did we do? We looked at inheritance classes. And I showed you a lovely PowerPoint on what inheritance classes were and going through how to implement them within Unity. So if we quickly have a look, what we did was that we created this enemy class, which was our main base or our parent, and we said from this that we can dictate health, speed, collect, and an attack. And we then created this and put that into Unity. We then created our skeleton script, and we said instead of deriving from this was going to derive from its parent enemy. And when we checked that, so when we went onto Unity, let's clean with that, we clicked onto our skeleton enemy, and you can see we've got health 100, speed 50, collect 0, and we tested that again with another enemy called crab as just an example, and we could change those fields as well, making it a lot easier to implement enemy systems, just essentially a lot quicker. So what I'm going to do today is get our skeleton enemy moving from point A to point B on this platform, which as you may have noticed, I've just added on since the last time we created, or the last time I did this video. So first things first, we're just going to concentrate on the skeleton. So not to confuse things, I'm just going to delete, because it was just an empty, everything to do with crab. Cool, so awesome, got rid of that, and so we're just concentrating on our skeleton enemy. Okay, so once you implement anything in with an inheritance class, it automatically, or inheritance classes, it becomes an abstract, and essentially what that means is essentially the same meaning as an inheritance, but it's just in kind of C# language, more than just Unity language. So, but we have to set that class. So what we're going to do is go into our enemy script, and as you can see here, it's a public enemy class at the moment, and we've dictated health, speed, collect, and attack, which we can see in our skeleton. But as we've dictated, and what we said with the inheritance class, is that we want to change things within the skeleton, and to be able to do it, it needs to be abstract, it needs to be move around, and we need to override things as well. And that's another keyword I've just implemented there, which we're going to use. So what we're going to do first is get that ball rolling. So what we're going to do is, if I change this from public class enemy, if I change this to abstract class enemy, public void attack is fine. And then what we're going to do is allow the child script to be editable and do its own thing. So what we do there for that is by saying public abstract void update, and that's all we need for that. That's essentially all we need for that. And then this will allow skeleton to create its own update, and any enemy script for this circumstance, any enemy script to be custom within update. So now we've done that, we can customize what we want within that skeleton script, using our abstract, or allowing abstract to be used. So in the skeleton script, what we would do is, as you can see, we've now got a red line there. So what we need to do is outline this. So what we need to do in the skeleton script, we need to just add a private void start, because we will need that eventually. Oh, that didn't go nice, did it? Didn't like that. It just created those two. Cool, fine. And then what we can do is write public abstract oh no, it's not public abstract, sorry. It's public override, because we're now overriding whatever is being said within our enemy. So we go public override void updates with, this always does this new implementation. There we go. As soon as we've got rid of that, we've got rid of our red line, because we're overriding anything that's happening within our script here. We're allowed to customize this now. And this is where we're going to put our point A to point B parts within our script. I'll go into more detail about abstract and overrides as we continue creating different enemies for our game. But I thought I'd quickly brush into that because I went into so much detail with inheritance in the last video, just making sure that abstract allows us to edit, to be specific, do specific customs to the child scripts or the derived scripts from the base or parent script. Okay, so now we've done that, we can have a look at creating our point A to point B. So if we should we do this in this script? No, actually what we'll do, if we go to our enemy script, we can change some bits up. So and this is a cool thing to show you actually. So what we're going to do is, I showed last video I showed you the access modifier, so public, private, and a new one that you may not know about, protected, which is a hybrid of both, of public and private, but only works within the script. So what we're going to do is, this one is going to be called protected. So this is going to be a protected transform, and we're going to call this point A to point B. There we go. So we can have two different transforms in there. And what we're going to do is, obviously, if we save this now and then have a look at Unity, we can see that it hasn't appeared in our skeleton script, because rightly so, it's protected. So if we go back to Visual Studio, and just like we've done in so many previous scripts, we've used serialized field. This will work here as well. So we go serialized field, Command and S, make sure skeleton hasn't got any issues. There we go. Cool, save that as well. Come back here. What's happening to Unity? Oh, that's okay, don't worry about those things. And now we can see point A and point B have appeared, because again, serialized field works with protected and private as well. But obviously we want it to be seen in the other script, which we can because it's protected. Cool, so what we've done is added point A and point B. So now we need to create our point A and point B. So what I'm going to do is what can we do? I know what we can do. Let's do this. Right click on here, create an empty, and I'm going to call this point A underscore skeleton, and duplicate this and call this point B. There we go. So now I've got point A and point B. What I can do is, there should be zeroed out. So what I'm going to do is, I'll drag them out first. So what I'll do is highlight these two and drag them out of my skeleton enemy, and I only created them in there to grab their initial positions. So point A is here, which is perfect. Point B I'm going to grab and drag along to here. So we've got point A and point B for our skeleton. Okay, so at the moment I think our skeleton is just a sprite. Cool, so what I might quickly do is add a idle to him, an idle animation as well, so we've got a little bit of movement. Okay, there we go. Oh, we did cut him up, didn't we? Awesome. So where's our animation tab? There we go. So yeah, I want to create one for him. Create and sprites, night, tile map, animations, idle walk. Okay, so that's for okay. Let's create animations. New folder. Enemy. Like a good folder I do. Create. And then in there we can call this idle underscore skeleton. Click save. Lovely jubbly. What we're going to do now is how many? Oh, we've got a fair few. So if I quickly select these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Very odd number of frames there. 11. Okay. And what I'll do is quickly press record. Drag these in. It's not allowing me to drag those in. Come on, why are you being so silly? Oh, what's going on here then? Yeah, so we've got 1, 2, 3, 4. Come on. Be silly. There we go, that's better. No idea what was happening before. Drag these guys in. There we go, working. Great. So what is that? 11 out of, that's so weird. So if I change that to 11, my sample to 11, unrecord, press play, and then I've got a funky looking idle animation for my character. What if I change it to 12 frames so it just goes a little bit quicker? Cool, I quite like that. Cool, so just so he's got a bit of a movement, and we've now started up our animator and everything in there. And within our animator we can create our walk and everything a bit later on. So let's go back to where we were. So we've got point A, point B. So once we've got that, and as we can see, we've got point A and point B on our scripts. Let's drag point A and point B before, let's get this done before we start scripting, and they should both go in there just like that. Fantastic. Right, let's implement this, and hopefully we can test this out. So let's have a look. On our skeleton script, we're going to do a void public override update. So if we say what we're going to do, so it's a transform position. So if transform.position of equals point A dot position, what are we going to say? So if we have a quick look on scripting API, and let's type in vector3 move towards, is that what it is? Vector3 move towards. Let's have a look at this, see if this is correct. 19.3, yep. Use the move towards member to move an object at the current position toward a target position. Lovely, that's exactly what we wanted. Good guess. What have they done? Let's have a look at the script. Target dot new position. Okay, transform new position dot vector3, new vector3, and then let's state the position. That seems, you know what? The easiest always seems the most easiest. Okay, so position the cube at the origin, create the position in the cylinder, and reduce the size. Not reducing size. Yeah, we'll just move it to a new vector3. That is it. That's as simply as easy as that. So if we say, so transform dot position. So let's say transform dot position. Was it equals vector 3 dot move towards, and then it's, what would it be? So it would be our transform dot position for the x, and then it would be point, we want to go to point B to start off with, don't we? So it would be point B dot position, and then we obviously have to add our speed in there. So speed is then times by time dot the classic delta time dot delta time. Yeah, I think that's good. I'm not too sure. Else if transform dot position equals point B dot position. So this is us coming backwards now, coming back to from point B back to point A. So we would essentially say the same. Transform dot position equals a vector 3 dot move towards again, and then if I'm not mistaken it should be point A dot position comma speed times by time dot delta time. Cool. Okay. So our transform position is going to go into a new vector 3 of move towards a target of transform position of point B at the speed of time dot delta time, and pretty much we're saying that, but back to point A from point B. Lovely. Nothing doesn't look wrong. Equals. Yes, that's fine. That's good. Lovely. Okay, let's quickly test this scene. I'm not feeling confident about it, and I think I know why, but I'll unveil that in a second. Camel Unity, what's going on? Cool. So if I press play, oh, okay, so he's kind of moved a little bit forward, but hasn't gone for it. Okay, so what's happened? Number one, I'm just going to change that to 0 and change that to 2. And I think I know why that's happened, and that's because we have put it into update. So what we've created is a bug issue. So if we look at this, and I was thinking this while I was writing it, update, as we know, absolute rookie error, is every 60 frames per second. So this, the point A position here is being read every 60 frames a second. So it's going, reading this, then quickly reading that, and then reading this again. So it's going back to, I can't remember what I've done there. Oh no. Always reading this every 60 frames per second. So only moving only slightly before it's reading point A again and adjusting this back. So what we need to do to stop that is creating a variable, which we will do right now. So if we say private bool, so it's a true or false statement, so it only can be seen once. So we'll call this switch. Oh yes, private. So switch. So let's say just equals false, so I know what's going on. So private bool switch equals false to start off with. So we need to say, what do we need to say? We need to say if underscore switch equals false. We need to say this here. we need to say, I think so, yeah, let's do this, let's try this. As I say, never copy and paste and then look at me. So let's put that into there. And then else if will be underscore switch equals true should then be this part. Copy, paste in, lovely, lovely. So, and then what we can do is for this, we can say underscore switch equals false. And then here we can say underscore switch equals true. I think that should fix it. So if it's a true or false statement where it's waiting for that ball now, that should work. Right. If it doesn't, I don't know. Okay. Save that again. Double check. Lovely. Only silly little errors. Not worried about those. Got all that sorted. Speed of 2. Let's press play. Grit our teeth because I think, yes, there we go. Fantastic. So there we go. We've done it. We have implemented our skeleton character. We haven't got the walk yet or the flip, but we'll get that all sorted out. I might move that point B back a little bit, but that is working lovely, jubbly. There we go. Fantastic. Good to see. Cool. Okay, I hope you've enjoyed this tutorial on abstract classes and waypoints for our enemy characters. Next one, I don't know what we'll do for the next video, but I'm sure we'll probably maybe do more enemies or get that walking sorted or flip that sprite or something like that because it's already annoying me. Okay, cool. Hope you enjoyed this video, guys. See you soon. Thank you. Bye bye.